In this work, we propose a novel tensor-based approach to support iterative partitioning and multidimensional pattern extraction in large-scale spatio-temporal data. Let's first take traffic volume data as an example. We can describe it as a tensor with 3 dimensions including days, hours, and spatial regions, and each entry records the traffic volume accordingly. Rank 1 non-negative tensor decomposition generates a set of latent vectors which describe the distribution of traffic volume over days, hours, and spatial regions. In combination, they approximate the original tensor data. We propose a novel algorithm which simultaneously slices the tensor into homogeneous subtensors and extracts the latent patterns for each partition to better reflect the variation across different subsets of data.
Built on the algorithm, we propose TPFlow.
The tree view tracks the iterative partitioning process. Each node presents a subtensor. Users can directly interact with the node to further partition the subtensor on a selected dimension. The node can also be resized for further exploration. Every action is reversible by clicking the backward button. Users can select a set of nodes to compare the latent patterns from different subtensors. Users can also toggle the box plots in the charts to show how much the original entries in the tensor deviates from the patterns.
TPFlow
also supports manual selection and partitioning. We demonstrate 3 usage scenarios with real-world data. The first usage scenario is regional sales data analysis. The dataset is modeled as a 3-way tensor shown here. The analyst wants to identify products with similar trends of demand distributed over time and geographical regions in order to search for cross-bundled selling opportunities. After loading the data, the analyst toggles the box plots to check the deviations and split the products accordingly. The pink product group is quite consistent in the spatial and temporal distributions of sales volume. The orange product group starts to sell after April 2015. By further splitting on the orange, the analyst observes that one product has much more sales in these 3 states. The analyst is interested in one group of products. Then he selects the data from the second year and examines the difference across different states. One interesting pattern he found is that the pink group in the northeastern region of Germany performs significantly different from the other states. For example, they have an outstanding peak in June and their sales are almost entirely contributed by one product. The second usage scenario analyzes customer traffic in a brick-and-mortar department store. The dataset is modeled as a 3-way tensor with 2 temporal dimensions. Analyzing the data can reveal insights for better management of store hours, store layout, staff capacity, and etc. The system recommends splitting the days into 4 groups in the beginning by using the optics clustering algorithm. Different hourly trends can be observed for different days. For example, the green is for the Saturdays and the orange is for the Sundays. In general, the Saturdays and the Sundays have the largest number of customers. However, on Sundays the customers appear to leave much earlier. The analyst is interested in the performance of different retail areas. He selects the weekdays and the daytime business hours and then iteratively splits the retail areas. In total, 6 groups of areas are identified. He finds that they have similar daily and hourly trends, just at a different scale. The zones closer to the center have much more traffic. The zones on top have relatively more traffic, as they are close to the main entrance. In general, the zones on the right bottom side have much less traffic. The small deviations displayed in every chart indicates the reliability of the patterns identified. The last use case involves New York taxi trip data analysis. The dataset is modeled as a 4-way tensor with 2 spatial dimensions. The analyst first separates the days. He observes the green group contains the 3 days, including Independence Day. The orange group includes all the non-holiday weekends, and the purple group has all the normal weekdays. They have very different hourly patterns, which can be observed in the line chart. The flow map further shows the top 6 OD flows for each group of days. The distributions are also quite different. The analyst wants to study the behavior in different zones during the weekday's morning rush hours. He partitions the node on pickup zone. He first found the top K flows from different groups merge in one zone. The green zones have very similar shape with the Upper East Side, one of the largest residential areas in Manhattan. Moreover, the green zones have a very different drop-off pattern compared to the other zone groups. The majority of passengers from the green zones take taxis only to a few nearby areas. However, the destinations for the passengers from the orange zone spread more to the bottom of Manhattan and more averagely.